Welcome to the Semester 2 exam review video for Honors Geometry. So let's begin with Chapter 6. And as we go through this video, realize I may not go through all the details on every question, especially if they repeat concepts of others. So after the video, please make sure if you have any questions remaining on the review or how I got some of the answers or how to arrive or a different explanation, let me know before your final exam. So looking at our first few problems, looking at the idea of symmetry. So first, for the figure, draw the lines of symmetry. So our first figure, we'd have 3 lines of symmetry on the equilateral triangle. The regular hexagon, all regular figures, have the same number of lines of symmetry as sides, so we'd have 6. And then our isosceles right triangle would have 1 line of symmetry. In 4, clock face have rotational symmetry. So can we rotate this figure less than 360 degrees so it would look the same? Well, if we rotate it 90, this flat side would be where this point is, so that wouldn't work. But if we rotate it 180, it would look exactly the same, so it has rotational symmetry of 180 degrees. Does the figure in 6 have rotational symmetry? It has threefold rotational symmetry, 3 different ways that it would look the same. So then 360 divided by 3 tells us that it's a 120 degree rotation for its symmetry. In 7, we're looking at the kite, K-I-T-E, and we're looking for the measure of angle K-I-E. So right away, because this is a kite, I know angle K-I-E and angle T-I-E are congruent. So that measure that we were given for angle 2 is the same as the measure for angle KIE. And then we know that the diagonals intersect at 90 degrees in a kite. So in this case, we would know that the measure at angle 1 was 90 degrees. So if 15x is the measure angle 1, 90 equals 15x, so x is 6. Plug that in to 3x plus 5 to get the measure angle 2, which was the same as KIE. So 3 times 6 plus 5 gives us 23 degrees. In 8, solving for B and A, apologies here, I had to flip-flop them, but angle B would be 107 degrees. Angle B is the same as angle T because it's an isosceles trapezoid. Base angles are congruent. And then angle A is supplementary to 107. So 180 minus 107 gives us angle A of 73 degrees. And then we know the opposite sides are equal, so 2x minus 1 equals 13. So x would equal 7. 9, A through E, true or false? Diagonals of a rhombus are perpendicular is true. Every parallelogram is 4-sided, quadrilateral, that's true. Diagonals of a kite are congruent is false. If a quadrilateral has 3 right angles, does not make sense, so cross that off. And in E, a pentagon with all congruent sides must be regular. If it is a convex pentagon, which that's what I'm considering in this case, that would be true. In 7, Chapter 7, I should say, we're looking at triangle congruency. So we're thinking about our triangle congruence theorems, such as side, 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 angle, side, hypotenuse, leg, and so on. So in these cases, we're determining if the triangles are congruent. If so, which theorem or postulate. In 10, 3 sets of corresponding congruent sides, so it'd be side, 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 congruent. 11, we have the shared side that's congruent, and two sets of angles. So we'd have angle, angle, side congruence. 12, all the angles are equal, so that means the triangles are similar but not guaranteed to be congruent, so that's a no. 13, we have a 90-degree angle on each. We know a leg that's congruent. They share a hypotenuse, so we could use hypotenuse leg congruence. In 14, mark all pairs of congruent corresponding parts, and to identify them, so you could mark them in the diagram as you see here, or write them out as you see here. 15 and 16, asking what information is missing to use the given theorem. So to use hypotenuse leg, well, we already know the 90-degree, we know the shared leg, so we would need to know that side PR is congruent to PQ to use hypotenuse leg. In 16, side angle side, we know the shared side and then the opposite sides. So we would need to know that angle ABD is congruent to angle CDB. 17. We know in this case that we have congruent triangles, and we know the opposite sides are congruent, so 4x plus 8 equals 7x minus 4. Solve for x. X is 4. You can see the work right there. Naming the special types of quadrilaterals whose diagonals bisect each other. Those are listed here. Are congruent. Those 4 or 3 are listed here. And are perpendicular to each other. Those 3 are listed there. Then, Chapter 8. So, Chapter 8, we're looking at some missing side lengths, ideas of area and perimeter. So, looking at the diagram, all the angles are right angles. They gave us the side lengths. So I know my missing measurements for MW was 12, RM was 4. So perimeter, add up all the exterior, is 64 units. The area, we can break this into two rectangles. One is 8 by 4, the other is 8 by 20. So 32 plus 160. Area is 192 square units. Finding the length of the leg of the right triangle, approximate to 3 decimal places. So using Pythagorean theorem, we know leg 1 squared plus leg 2 squared equals hypotenuse squared, or a squared plus b squared equals c squared. So a squared plus 22 squared equals 24 squared. Subtract the 484 from 576. A squared is 92, so a is the square root of 92, or approximately 9.592. 21, the word problem here. So if we draw a diagram of the scenario, we know that the string is atop a 12-foot pole, and that the point on the ground is 6 feet from the pole. So we would use Pythagorean theorem again. 6 squared plus 12 squared is that x squared. So 180 is x squared. X is the square root of 180, which is 6 square roots of 5, or approximately 13.416 feet. 22, again, Pythagorean theorem. X squared in this diagram plus 24.1 squared equals 25.5 squared. Set up our problem. X squared equals 69.44. Square root of 69.44 tells us that missing value is approximately 8.3 feet. 23 and 24, plus then 25 and 26. So those 4 problems dealing with our special right triangles. 23 and 24 are 30, 60, 90 right triangles. We have the 30 here, 90 here, meaning that's 60. So in a 30, 60, 90, if we would call our short side x, then our long leg is the square root of 3 times that short leg, and the hypotenuse is 2 times the shorter leg. So in this case, I knew my shorter leg was 5. So my longer leg would be the square root of 5 times, or not square root of 5, would be 5 square roots of 3. And my hypotenuse is 2 times the shorter leg, or 10. In 24, to find x, that would be the hypotenuse divided by 2, so x is 11, and y is that shorter side, so x of 11 times square root of 3. In 25 and 26, we have 45, 45, 90 right triangles, so we know the two legs are the same, and the hypotenuse is the leg times the square root of 2. So in this case, our hypotenuse is 8. So to find our missing leg of x, 8 divided by square root of 2. So to simplify that, multiply top and bottom by square root of 2. So that's 8 square roots of 2 over 2, which would be 4 square roots of 2. 26, take our side length times the square root of 2 to get our hypotenuse. So simply h is 4 square roots of 2. 27, area of a triangle. Area of a triangle is 1/2 base times height. Remember, base and height have to meet at 90 degrees. So 1/2, 9.5 times 3.4, 16.15 centimeters squared. Area of the parallelogram, 5 times 15, base times height, or 75 centimeters squared. Area of the trapezoid. So we know it's a trapezoid. So area of a trapezoid formula is base 1 plus base 2 in parentheses multiplied by the height of the trapezoid multiplied by 1/2. Base 1 is 7, base 2 is 3, height of the trapezoid is 4. So 10 times 4 is 40, times 1/2 is 20 square units. Area of the shaded region would be a rectangle that's 34 by 14 minus the 2 semicircles, or a circle with a radius of 7. So area of the rectangle minus area of the circle. So area of the rectangle, 476. Area of the circle, pi times radius squared. 7 squared is 49. So our answer would be 476 minus 49 pi, which is approximately 322.06 square units. 31. We know circle has a radius of 7.39. Measure angle AOB is 112. Find the length of AB to 1 decimal place. So we're finding the length of arc AB right here. So first we'd find the circumference of the circle. 2 times pi times radius. So 2 times 7.39 times pi, or 14.78 pi. Multiply that by the fraction of the circle based around our angle measure. So our whole circle's 360, angle measure is 112. So 112 over 360 times 14.78 pi, giving us 14.445, or 14.4. Now, in 32, they tell us to use 3.14 for pi, and we're finding the area of the shaded region with a 60-degree angle measure, and the radius of the circle is 8. So first we want to find the area of the circle, pi times radius squared, or 64 pi. The shaded region is 60 degrees of the 360, which would be 1/6 of the circle. So we would take our circle area, 64 pi, times 1/6, to give us the area of the shaded region. which is 10 2/3 times pi, or approximately 33.49 centimeters squared. Now into everyone's favorite surface area. So we need to remember for prisms, surface area, and for cylinders is equal to the lateral area plus 2 times the area of the base. So first we want to look at 33. We have a right prism below and equilateral triangles for the bases with side length of 4. Height of the prism is 5. Find the surface area. So first we'd want the area of a base. So the area of a triangular base, 1/2 base times height. Well, we know the side lengths are 4, but we don't know the height. So to find that height, we would think about Pythagorean theorem. 2 squared plus x squared equals 4 squared. So the height of that triangle is the square root of 12, or 2 square roots of 3, approximately 3.46. So the area of each base would be 4 times 2 square roots of 3 times a half, which is 4 square roots of 3. Then we need to find our lateral area. Lateral area is the perimeter of the base times the height of the prism. Perimeter of our base, 4 plus 4 plus 4, 12 times the height of the prism, 5. Lateral area is 60. Surface area is the lateral area plus 2 times the area of the base. So 60 plus 8 square roots of 3, or approximately 73.86 centimeters squared. Surface area of the cylinder. Find the area of our base, radius squared times pi, so 7 squared times pi, is 49 pi. Lateral area would be the perimeter of our base times the height of the cylinder. Perimeter of a base is circumference, so 2 times pi times radius, and then times the height of the cylinder. So 2 times pi times the radius, which is 7, height of the cylinder is 12, gives us 168 pi. Then our surface area formula, lateral area plus 2 times the area of the base, 168 pi plus 2 times 49 pi. So that gives us 266 pi centimeters squared, or 835.66 pi, not pi, 835.66 centimeters squared. All right, moving on to our pyramid. So now we know the surface area of a pyramid is the lateral area plus the area of its singular base. So our lateral area is 1/2 the slant height times the perimeter of the base. So we have our slant height here is 7. Perimeter of the base, which is a square, would be 20, 5 times 4. So our lateral area, 1/2 of 7 times 20, which is 70. Area of our base, which is a square, would be 5 squared, or 25. So our surface area is 70 plus 25, which is 95 square feet. Then we get into surface area of the cone. First, for surface area of the cone, we need to find the slant height. Use Pythagorean theorem. 3 squared plus 11 squared equals our slant height squared. Here's the setup for that. So our slant height is the square root of 130, or approximately 11.4. Find the area of our base, pi r squared. Radius is 3, so the area of the base, radius squared, which is 9 times pi. So then, to find the surface area of the cone, we would take our lateral area plus the base. So we need to find our lateral area. So we knew our slant height of 11.4, or square root of 130. Perimeter of the base which would be 2 times pi times the radius, so 6 pi. So our lateral area is 6 pi times 1/2 times 1/3 square root of 130, which is 3 times pi times the square root of 130, or 107.46. So 3 pi square roots of 130 plus 9 pi, or approximately 135.73. Then getting into our final chapter, chapter 10, our volume formulas. So volume of the prism would be area of the base times height, area of our base, triangle, so 1/2, 4.5 times 5, giving us 11.25. Height of the prism, 8. So volume, 11.25 times 8, is 90 cubic centimeters. Number 8, or 38, volume of this figure. So it's the volume of the cone plus the volume of the cylinder. So volume of a cylinder, area of the base, pi times radius squared, times the height of the cylinder. Radius is 4, height of the cylinder is 6, so 4 squared times 6 is 96. So the volume of our cylinder is 96 pi. Volume of the cone would be 1/3 area of the base, pi r squared, times the height of the cone. So then, volume of our cone, 1/3 pi, 4 squared, our radius, again, times the height of the cone, 7. That gives us 37 1/3 times pi millimeters cubed. So then we can add the cylinder, 96 pi, plus the cone, 37 1/3 pi, giving us a total volume of 130 1/3 pi millimeters cubed, or 409.45 millimeters cubed. And then our final two questions on the review. 39, we have a rectangular pyramid, and we know the faces are isosceles triangles. Find the volume. So volume formula for a pyramid, 1/3 area of the base times the height. Area of the base would be 2 times 6, because it's a rectangle. So that's 12. Height of our pyramid was given to us at 8 feet. So 12 times 8 times 1/3 would be 96 divided by 3, so 32 feet cubed. And our final problem, volume of a sphere with a diameter of 7.2 inches. So volume of a sphere formula would be 4/3 pi r cubed. So our radius would be 3.6 if our diameter is 7.2. So our volume formula would be 4/3 times pi times 3.6 to the third power. So that gives us 62.208 pi, or approximately 195.43 cubic inches. So after going through this video, looking at the PDF, if you still have questions on any of these problems or how to get the answers, want a different explanation, please make sure to ask before your final exam.